The implicit purpose of this exercise is maximization. It is suggested in the text formulation, which refers to the maximum shelf space that you can allocate to one drink, which is 6 meters, when the minimum can't be less than 1 meter. But we talk about maximization, that's all right, but what can we maximize? One might think that maximization should be based on margin indicators, whether the total contribution margin in absolute terms, in euros, or the relative contribution margin in percentage. But you could imagine also to maximize sales or quantities rather than contribution margin. Some companies favor sales as their primary objective. Hence, they give sales target and incentives to their sales force. Perhaps the manager of this company doesn't own the store, and maybe she receives a commission on sales. The problem with sales is that the maximization doesn't necessarily lead to the maximization of contribution margin. So, what can be the right reasons to maximize revenue rather than contribution margin? For retailers, selling more allows them to collect more cash because they collect money from their clients before paying their suppliers. In the meantime, they can get interest from the cash they collect. Also, you could try to maximize quantities. That's maybe a way to obtain a discount on volume, which would allow an improvement of the unit contribution margin because the variable purchasing cost of the goods sold would decrease. Nevertheless, whatever you decide to maximize, there is one element here which has to be taken into account. That's a constraining factor, that is the 12 meters of shelf space which are available. And there is a rule, which is written here, which consists in allowing as much constraint factor as possible to the activities that maximize the targeted indicator for 1 unit of the constraint factor. Let's take an example. So our constraining factors are the meters of shelf space. If we want to maximize the contribution margin in euros, we must give the maximum shelf space to the drink that maximizes the contribution margin in euros for 1 meter of shelf space. If, on the contrary, we want to maximize sales, we must give the maximum shelf space to the product that maximizes the sales for 1 meter of shelf space. This idea, we are going to see it more in detail in that slide, which is here. If we consider the sales per meter of shelf space, which are calculated here, which are the price of a case, which is 24 cans, and times the number of cases sold for 1 meter of shelf space, we get the following numbers. We see that the lemonade is the drink which maximizes the sales for 1 meter of shelf space. Then comes the cola. So, since we have 12 meters, we will allocate the maximum shelf space to the drink which has the highest sales for 1 meter of shelf space. The maximum quantities we can allocate is 6 meters. Then we have drinks which generate a low level of sales per meter of shelf space. So we will allocate such drinks the minimum quantities. They will be ranked number 3 and number 4 in our allocation because we want to give them the minimum number of meters. And that minimum number in the text was 1 meter. So we would give 6 meters to lemonade, 1 meter to soda fruit, 1 meter for orange juice, and remains 4 meters to allocate to cola, which is the drinks which ranks second. So we'll rank first lemonade, and then we rank second the cola, and third and fourth drinks are orange juice and soda fruit. and that's the two drinks we will focus on primarily. On the contrary, the two other drinks, soda fruit and orange juice, we minimize the shelf space we give them. Now, if you look at how we would allocate the drinks, the shelf space for the drinks when we want to maximize the contribution margin, we get a different perspective. Now it's not the lemonade which has the highest contribution margin per meter of shelf space, that's the cola. And then the drinks which rank second will be the orange juice. So if we consider the orange juice, it will rank second. If we consider the cola, it will rank first. We will give the cola 6 meters. We will give the orange juice 4 meters. And then, for the two drinks which remain, which rank number 3 and number 4, they will get the minimum quantity of shelf space for lemonade and soda fruit. And you see that it's a pretty different allocation than the one we used for maximizing sales. We don't rank by the drinks the same way. So we see that depending on how we rank and allocate the shelf space, we get very different performances, and every time we try to maximize, we get a certain quantities, either of cases sold, of sales in dollars, of contribution margin, or of contribution margin ratio, and there is just one way to get that maximization, the one which is described here. If we look at what maximizes sales, we get a maximum level of sales of 5,222 and a margin which in that case is equal to 890. But if we were to maximize contribution margin, so the other combination gives a lower level of sales here, and if we want to maximize contribution margin here, we do get the higher level of contribution margin, but for a lower level of sales compared to the previous, to the row just above, which aimed at maximizing sales. And that amount of contribution margin that we get is the maximum. We get less with any other combination. So we do see again that the shelf space allocation that maximizes sales is not the one that maximizes the contribution margin in euros. And we get this insight that profitability and activity are two different dimensions of performance, and that they don't necessarily go hand in hand. Again, we have a more detailed perception of the difference between maximizing sales and maximizing contribution margin. The third option of ranking, which you see here, would give the maximum level of sale. The fourth option of ranking the drinks would give the maximum contribution margin. When we move from option 3 to option 4, we gain an opportunity of margin, which is $80, but we lose an opportunity of sales. So again, we do see the difference between maximizing sales and maximizing contribution margin. In order to conclude that exercise, I wanted to present you a different perspective, and instead of thinking in terms of maximization, we can also try to make an optimization, which would be to find a compromise between getting the maximum contribution margin or getting the maximum sales. And if we look at, for instance, the first drink, cola, we see that cola allows to get the maximum sales when you allocate it 4 meters, and if you allocate cola 6 meters, you would get the maximum contribution margin. So I made a trade-off, and I thought, let's give to cola 5 meters only. We know that so doing, we wouldn't get the maximum sales, we wouldn't get the maximum contribution margin, but we would find a middle way, okay? Then the situation is much more constraining when it comes to lemonade, because you really have to, for lemonade, you have to decide if this is sale that you want, and in that case you would give the maximum shelf space to lemonade, or you decide on the contrary to maximize contribution margin, and then you would allocate, and that would be the opposite, the minimum number of meters you can allocate to that drink. So again, I thought, let's imagine a compromise. let's cut the shelf space allocated to lemonade, and let's so decrease the sales of lim all in all, because we wouldn't give 6 meters to lemonade, but only 3 meters. Those 3 meters that we don't give to lemonade, we would give them to orange juice. The orange juice would receive 3 meters. And so, giving more meters to orange juice is good for contribution margin and bad for sales. So we see here that instead of getting the maximum sales or the maximum contribution margin, we would get intermediate performances. And so this is the change in allocation that we implement. 3 meters instead of 6, 3 meters instead of 1. And so you see that instead of getting the maximum sales, we would get $417 less with sales that amount to $4,829. And we would get a lower contribution margin than the maximum we could achieve with $50 less, but that would be an optimization rather than a maximization. We can observe a dynamic simulation exploring this idea where we would give less and less meters to lemonade and more meters to orange juice. So if we look at that Excel simulation, which corresponds to the screen capture I showed you before, nevertheless, here I've created a dynamic simulation using a scroll bar, and you see that instead of 6 meters of lemonade, here I have 3.9 meters of lemonade. Instead of 1 meter of orange juice, I've got 2.1. So by having done this, I have degraded the total amount of sales, because to get more sales, I should have given 6 meters to the lemonade drink. And I've also degraded the contribution margin of orange juice, because I don't give 4 meters to orange juice, I just give 2.1. If I keep on decreasing the shelf space allocated to lemonade to reallocate it to orange juice, I will see progressively that my sales will decrease and that my contribution margin will increase. Let me show you this. You need to observe this chart below, the evolution of sales, the evolution of contribution margin. So you see that the sales go down. You see that the contribution margin progressively increases, and that the more space I give to orange juice and the less I give to lemonade, the more I put forward the contribution margin rather than the sales. Again, that reminds you that in this problem you can't get the best of both worlds. You have to choose between sales and profitability.